Hi, my name is Marco Panizza and I'm working at Panasonic Industry, looking after technical marketing and new business development in the field of power electronics. Power electronics means for us power semiconductors, and here today at PCIM I want to introduce you on our new X-GaN technology, which are enhancement mode GaN solutions for high power and high frequency switching operation. Our GaNs are now in mass production and have been fully qualified for any type of applications. Our GaN is an enhancement mode device. It is normally off. It doesn't need a cascode configuration, but it's driven by injecting charge into the gate. As I said before, the GaN is fully qualified, and we put a lot of emphasis on one specific aspect of reliability, which is what we call the current collapse. GaN devices have the peculiarity of trapping charges in the channel, in the high electron mobility channels. With our technology, with our patent, we can absorb those charges, and therefore we guarantee a current collapse-free operation. We guarantee that the RDS on of the device will never change under switching condition at high voltage. So it's an advantage of using this type of device. There is no need of specifying any dynamic RDS on. The GaN devices that it proposed today are already in mass production, and we have a lineup of 4 different type of packages and current sizes. The 2 which are now in mass production comes in a package of 8 by 8 millimeter, and we have a version which is rated for 13 amps and a version which is rated for 26 amps. Both of them has a breakdown voltage of 600 volt, guaranteed up to 750 to maintain some margin during operation. We are developing now, we are delivering samples of a higher power device, which is the 52 amps device in a DSO package, and a smaller device in a 6x8 package, 4x6 package, which is rated at 8.5 amp. This is meant for application like home automation, lighting, where the size is important, the power is not so high, and of course there are concerns about the cost of the system. Typical application for GaNs are normally high power and high efficiency power supplies. If you think about supplying a high performance computer or a server blade, where you have a number of power supplies running in a server farm, you need to increase the efficiency as much as you can in order to maintain the utility cost low, to control the cost of ownership, and eventually to reduce the volume of the complete installation. With a GaN, this is made possible because the GaN is a high-speed switching device. It can switch at much higher speed than a MOSFET or a superjunction MOSFET, and therefore the magnetic components can be reduced in size. And by increasing the efficiency, also the cooling aspect is simplified. You don't need large volume of heat sinks, therefore the whole system will be compacted with reduced volume. An example is here. This is a conventional AC to DC adapter based on silicon components. By changing that into the GaN technology, it turns out to be on this size with the same power and the same performances, but much lower size. Another important topology that can be implemented with a GaN are the input power factor controller system. Normally, any AC-DC converter needs a power factor correction system, which is based on a typical topology of a boost converter switching. With GaN, it's possible to use what is called the totem pole PFC converter without the bridge, without the diode rectifying bridge, and with a significant increase in efficiency. A typical boost converter has an efficiency of about 97%. With a GaN, it's possible to push the efficiency up to 99% and more. And this is just a demonstrator that we developed. This is a 3 kilowatt input front end, PFC corrected. It delivers a constant high voltage DC for distributed power. And this, as I said, is a 3 kilowatt device with an efficiency in excess of 99%. So as I said, GaN is now for Panasonic a reality. We have the full qualification suite in place. We exceeded the JEDEC specification in qualifying the device. We are in mass production, and we are supporting customers with in many ways. We have all the collaterals ready, all the data sheets, all the application notes. We have simulation models, and we offer also evaluation boards like this one. When the customer needs to evaluate the GaN performances, he can use this board. It's a half-bridge solution. There is no need to assemble anything, just power up, apply the driving signals, and it's possible to measure the current with very high accuracy and check the voltages and in many test points, and really qualify the device before starting prototyping the final design. So this is our highlight in terms of power semiconductor at PCIM. Moving on, I'd like to show you another typical application of GaN. So by the time we'll move on, I'll show you that. Thank you very much by now.